In this lesson, we're going to be talking about file systems, and specifically, we're going to be talking about the file systems typically associated with Windows. Now, going back to the 1970s, there was a file system that was just simply called File Allocation Table, and what that represented was the way that files and directories were stored. They were stored in this file allocation table. Now, we've still got FAT or file allocation table disks around. You'll see them a lot on, for example, USB sticks. So I've got a USB stick here. It's actually formatted in FAT format. It's actually specifically formatted in FAT32. So the original FAT was a 12-bit file system. And so now we might call that FAT12. That gave way to FAT16, and now we have FAT32. The big differences there are the file sizes as well as the drive sizes that we can support. So this is a FAT32 disk. There are some limitations with FAT32 disks. Now, one of the limitations is the fact that I don't really have anything in the way of permissions, for example. So I've got this folder properties here, and it's called configs, and you can see that I don't really have anything that I can do with it. There's a read-only attribute, a hidden attribute, and an archive attribute, and that's really it. That's all I've got. Now, you'll see pretty commonly these FAT file systems on devices that need to be really portable, because FAT is such a common file system and it's been around for so long that pretty much everything supports it. So a USB stick is going to come formatted FAT by default because every operating system is going to be able to read it. Memory cards in cameras are probably formatted in a FAT format, again, because it's so portable everything can read it. Now, when Microsoft was developing Windows NT, they decided that FAT wasn't a good enough file system anymore. And so they went to FAT32. You can see the file system here is NTFS, and this is the C drive. I can bring up properties on a directory here. Now you can see, again, I've got the read-only attribute and the hidden attribute. But across the top, I've got several other capabilities, the big one being security. Now, with the FAT file system, I didn't have the ability to set permissions on any of the files or folders because there were no attributes like that. We didn't have the ability to have multiple users in a Windows system until we started using Windows NT. So now I've got this ability to set different permissions, and you can see I've got full control, modify, read and execute, list folder contents, read, write, and special permissions. So I could actually remove some users who had permissions on these files, and I can add users who have permissions. So I've got all of these abilities to set permissions on files, which gives me a lot of flexibility in terms of who gets to see them, particularly if this is like a server operating system where multiple users could actually get access to my files. I might want to prevent them from being able to write to a file. I may want to allow them to read the file, but not actually write to the file. So along with permissions, I get a number of other features in NTFS. Now, in other lessons, we've talked about alternate data streams. I get alternate data streams with NTFS. I also get encryption. So I should be able to go to advanced here, and now I can encrypt the contents here to secure the data. So NTFS has an encrypted file system among one of its features. You could actually encrypt individual files or folders. In addition to encrypting it, I can also compress them. So the file system has the ability to compress as well as decompress files and folders within the file system. Now, you'll also see that there's indexing. So NT also supports indexing, which allows for faster searches of the file system. One thing that you don't see very often, although it's there, is this idea of journaling. So what a journal is it keeps track of all of the writes of the file system, and anything that gets modified, it keeps track of all of that in a log. So if anything bad were to happen, it can go back and check the log against the actual file system and see whether they match up. If they don't, they can reapply the log and recreate the data that may have been lost through, for example, a power failure. So journaling is really important. Having that ability to log transactions on the file system, just like you do with a database, is really important. Now, one thing I can do with NTFS that I can't do with the FAT file systems is to create links. So what I want to do here is I'm going to run make link, and I'm going to say I want this to be a hard link, meaning that anything that changes in the link also changes in the target. So I'm going to say new koala.jpg, and I'm going to point it at koala.jpg. Now, if I do a directory listing here, I've got koala.jpg and I've got new koala.jpg. And they look identical because one actually points directly to the other. It's not a shortcut to that. Like you'll see when you create shortcuts, you'll see it says shortcut. This isn't a shortcut. It's actually linking directly to that koala.jpg. So NTFS gives me the ability to do these hard links. In addition to that, I also get things like quotas. So I can set a specific quota for a particular user, and they can't go above, let's say I give a user 2 gigs. They can't go above that 2 gigs. Something else that NT offers me the ability to do is have volume mount points. So I can go into Disk Manager here, and I could actually, let's change the drive letter and paths. I'm going to remove that E. And now I've just got this USB stick, and I can change the drive letter to mount into an empty NTFS folder. So let's say I'm going to say USB here, create a new folder, and I'm going to mount that USB stick into C:USB. Now, if I go back here, if I go into C, you'll see USB, and it's actually going to bring me to that USB stick. And it's now mounted as a directory rather than a different drive letter. So in Windows, we have drive letters, unlike Unix, where we have mount points. With NTFS, we also have the ability to do mount points, much like we do with Unix-like operating systems. Again, I've got this directory now called USB that's actually a mount point for this USB stick that I've got inserted. So with NTFS, I've got all sorts of capabilities that I didn't have with FAT. Again, we've got journaling, we've got hard links, encryption, compression, quotas, and permissions, among many other features. Now, with the current Windows operating system since about Windows XP, NTFS has been the default preferred file system, although you can still use FAT32 as your file system. But NTFS has been the default preferred file system for all of the reasons that I mentioned that NTFS gives users capabilities to do.